Okay, so where I left off, I had the code that I'd been writing for WAV files kind of in a good enough state that I had proved out the basic features that I want. And now I'm looking to do a cleanup pass. And I have a couple things in mind that I'm specifically thinking of doing during this cleanup pass. So I want to make sure that all of the code I've written has sort of a level of rigor to it. And what I have in mind there is just making sure things like I've done everything I can in the parse to minimize the chance of failing to parse something for little, there are odd spots here and there where there are different numbers that mean different things that kind of have overlapping meanings. And I don't want to fail on some files that other things work on because I didn't try to get the maximally lenient interpretation in my parser, right? So I want to do a pass to look at that kind of stuff. Same kind of idea on the writer, except the opposite problem. I want to make sure that when I'm writing a WAV file, I'm doing the most work that I can to fill out all of the fields so that I can be interpreted by just about anything correctly. And that's sort of what I'd call like the improving the rigor portion of the code. I also want to take a look at the design or the API of the code. I want to make sure that I've thought through how I can maximize the utility I will get out of all of this work while not overcomplicating it, right? I don't want to add in lots and lots of code. I want to keep the maintenance burden low. So a way I like to think about this is I want to make the effectiveness of my code high. And so I'm going to be looking for a good ratio of utility to maintenance burden when I'm doing that design pass. And then finally, there's just organization, which just sort of means putting things in places, giving things names that makes it all sort of regular and fit into the pattern of how everything else is working. So I don't have useful helpers in the wrong spot that makes it hard to move them around or use them from other pieces of code that might want them in the future. Also making sure that I have my naming scheme in a nice, simple way so my names aren't too long, but they're nice and descriptive. It's easy to predict them in the future when I'm trying to recall how to use this code, all that good stuff that just makes it, the small things, the things that feel like they don't matter when you're writing it, but that totally do matter when it's frustrating you later. So I want to go through these three things. I'm kind of actually going to start from organization because I have some helpers that I started writing for this code that I want to clean up first because the rigor part will be a little easier when I'm not basing it on helpers that are still disorganized. So I'm going to start with a little bit of organization and then we'll go through these. We'll make sure that the parser is rigorous and that the writer is more rigorous, and we'll try to work on the design, and then we'll do a final organization pass as well. All right, so let's get started. Okay, so what I just got done with was doing my cleanup work. So all three of the stages I listed that I'm going to do to all of the code, and I just applied it to these two swizzle functions first. I think the most important change was just that I moved it to the base layer, so it's no longer considered a part of Wave, but just a part of my whole code base. And that means if I ever have to deal with interleaved buffers the way I'm doing with the wave samples in any other context, it's just there and ready to go. Since none of this code really referenced wave types, there was nothing keeping it there. I just had to do a bit of cleanup on the names to make it more appropriate to the general case of it changing back and forth between interleaved buffers and separate buffers. This also already has an example of improving the rigor of the code a little bit. I had originally this assert that I've been able to get rid of because now the way the API is phrased and, improving the rigor and the API design can go hand in hand. The way the API was phrased before, I passed in a size and I had to assert that the size was actually a multiple of some of these other parameters. But as I was looking at it and cleaning up the way the interface worked, I determined I probably should just not pass in these buffers as strings and instead give them as void pointers and deduce the size by multiplying these other numbers together. And the reason that's better is because one, I'm getting rid of this assert. It also just means that everything is a multiply instead of a divide now. So it's sort of a win-win. We got rid of an extra parameter. We got the interfaces being more consistent between each other. All around, that looks a little better to me. So that's an example of what I mean by these cleanup things. We're going to try to do that kind of work on everything so that we end up with consistent interfaces, minimal amounts of, bad code paths or wrong ways to interact with a piece of the system. So we did these swizzle functions. Now I'm going to go through the parser. Okay, so I was able to sort out some questions that I had about the way I should organize the format code. It turns out that Riff is the sort of parent format or the fundamental format on which Wave is built. I kind of knew that, but I wasn't sure which types that were in my format file belonged with Riff and not with Wave, and I was able to track down some info that I think straightened that out. So I've got that straightened out now, so if we ever needed to parse a different Riff format, we could reuse the Riff stuff without having to pull in all of the Wave stuff. On a little bit more interesting side, I was able to do a couple things to improve the robustness or the rigor, as I called it earlier, on the parser functions. So I think the most important thing I did was straightening out how a couple of the fields in the format data actually need to get applied. The most important two that are sort of fiddly, they have different definitions depending on which format the WAV file is in according to the spec. And so it looked like you might have to track down all these ifs and elses and switches and stuff and fill in different interpretations of the fields depending on each case. But after I looked at it and thought about it, the cases basically boil down to that you have these two quantities. One's called bits per sample and one's called valid bits per sample. And the second one is optional. And with a couple of simple formulas, it turns out you can get everything you need to without knowing which case you're in, because whether you're in one case or another, there are restrictions on what's allowed and how to interpret them. And it turns out that in either case, the number of bytes per sample is just what you get when you round up the bits per sample to a multiple of 8. Oh, and I suppose I should probably divide by 8 there. I'm just noticing that now as I'm commenting on it. Let me put that on my to-do list. Okay, back. So the other thing I have to do is when I'm figuring out how many of the bits are actually valid, if the format does in fact include the valid bits per sample, it turns out that that just is always the thing to use, and it will always be less than or equal to the bits per sample in a valid file. So kind of like I stressed this back when we were doing the UTF or the Unicode encoding conversions. The main idea here is that for a good parser, that the way I want to do a parser, any well-encoded file I should be able to interpret correctly. If a poorly encoded file gets interpreted in a different way than it meant to be interpreted, there's not much I can do about that. But I can at least try to not crash on those. So the goal is don't crash or have terrible handling of anything. And if something is reasonably encoded, get it right without a lot of fussing. So in this case, it turns out that if the code is set up validly, that the min, or if the WAV file is set up validly, then the min here will always give me the right result. So this seems like a pretty nice clean way of getting these without having to do a lot of chasing down of different versions and different rules. Like I said, the valid bits per sample there is optional, so I have to have a plan for how I'm going to have one path when it is there and one other path when it's not. But the way I'm doing that isn't by having a bunch of deep nesting branches. Instead, I'm using the style where I have as much as possible, I rely on flat chains of conditionals and default values for one of the paths, right? So in this case, I'm setting the valid bits per sample to the maximum U16 value. And if it turns out we can't read the extension struct there because it's not in the file, then it just won't get replaced. And then when it goes to that min later, it will pick the other one. That way, this happens to be a default value I can put in that always gives the right result, even if there isn't actually an extension struct in the file, right? So that's what I'm relying on here to make that part work without a lot of fuss. And then I also, in just the part where I'm looping over the chunks and building a list of nodes that represent each chunk, I added in an extra clamp here. I think it's good whenever you're reporting the size of some data. If that size was read out of a file itself, you shouldn't just trust it. You should do something to make sure you're not going to end up reading out of that later if it's past the end of the file. So say a corrupted file has, a maximum U32 in the spot where it should have had the size of a chunk. Well, I don't want to allocate that much memory and crash, or try to read that much memory and crash or something. So I want to fix that as soon as possible in the chain. And one approach would be to say everyone who ever reads this needs to be aware that that could happen, and then this sort of error handling code will get sprawled out everywhere. My approach here is to just remove errors before they occur. So I clamped it to the actual size of the file so that it's always safe to read the amount of memory that I say I'm reporting here. That means that I won't detect errors in the file right away with a crash, but it also means I won't be surprised when after many, many tests I finally find a file that causes a crash, because I was just not testing a file that happened to be corrupted in the right way. It's still not possible to know for sure that I'm not going to crash until I do any kind of defuzzing maybe with this, but this is the kind of approach that I find tends to lead to less surprising and frustrating errors on other people's machines in the long run, I think. So that's the way I've set this stuff up, cleaned it up. The parser stuff is looking pretty good. I think I'll wrap it up here for now, and next time I'll do the same kind of pass on the wave rendering code that we've done on everything else. See you then.